So section 2.4 deals with writing linear functions. And so we're going to see them in different forms. We've already looked at the standard form. So the slope-intercept form is a classic that we normally use where y equals mx plus b, where of course our m is our slope and b is our y-intercept. Then we've got the point-slope form where you have still the y, but then you've got two of the ordered pairs. So you've got two of the coordinates here, which is the x1 and the y1. So two numbers that you come from the actual line. And so then you still have the slope, and then you have your x like you have up here. So the point slope form, if you notice here, it gives you a hint of what you're going to use it for. You've got a point in the graph, and you've got the slope. So here's the slope, and here's the 1 point, the ordered pair that we include in there. And so if you see a line in this form, it's easy to tell its slope and a point that it passes through, so you can do a quick graph. If two lines are parallel, then what are they? Well, they're two non-vertical lines that never touch, right? And they have the same slope. That's the important part here. If they're perpendicular, you have two lines with a negative reciprocal slope. So if one of them has a slope of like 1/3, then a perpendicular line would have a slope of 3/1 and negative. So you just flip whatever the slope is and make it the opposite sign. So you might have a direct variation. It's just a linear equation, but check this out. There is no plus b. So if there is no plus b, that means that it's 0. So these lines are the ones that cross through the origin. So they are considered a direct variation, and they have a constant of variation, the k, which is your slope. So I explain that in the next line. So the constant of variation is that k value, whatever number is here, that represents the slope. So you've got a slope, but you don't have a y-intercept listed. There's no plus b here, which means that b is 0. And so therefore, there is a y-intercept, but it's the origin. It goes right down the center. All right, so now let's look at the packet. So in your packet for 2.4, you've got some vocabulary, and look at the key concept as well. So here we see that when you have an equation in slope-intercept form, it's really easy for you to take the slope of this line and the y-intercept. There's some sample equations in practice to find the slope and so on, so go ahead and do those on your own. The answers are listed here. Another key concept here on slide 16 is that the slope-intercept form, so if you are given that y equals mx plus b, it looks like, yeah, it's the same information from before. So just a reminder of that. So let me continue. And so here, another note, and look at the picture of parallel and perpendicular lines. Like I mentioned, parallel lines have the same slope. So if the slope here is 2, then for this line, the slope here is also 2. For these here, if you have two perpendicular lines, notice the slope. In one case, you have 3/1, right? You can turn it into a fraction. And over here, you have 1/3 and negative. So that's how you can tell that if lines are perpendicular, they have the negative reciprocal slope. So in the study guide and intervention, you're going to have some problems to work on. And so you have first some examples to look at, and then we'll do some. So let me do one question from this section. It says to write an equation with the slope-intercept form for the line described. Okay, so let's just look at question 1. To write an equation, well, first of all, you need to know what an equation looks like, right? And I like my equations to be in slope-intercept form. So I need to find two things. Find a slope. Sorry about that. Let me delete this thing. All right, so I'm going to need to find a slope, and I'm going to need to find a y-intercept. So this equation, the slope is -2, so that one's easy. So step 2, I know that the slope is -2. So step 3, now I need to find what the b is. Well, if you notice, if this was 0, that's my y-intercept, but it isn't. So I need to find what the y-intercept is. So what I'm going to do is I'm going to take this equation and I'm going to use it. I'm going to do it here on the right side because I'm out of room to find the b. So I know the slope is negative 2x plus b. Now watch, I know an x and a y from here, from the actual information they gave me. So I'm going to substitute. So y is 6 is equal to negative 2 times negative 4 plus b. So now this is positive 8. 6 is equal to 8 plus b. I move the 8 over here, it becomes a negative 8. So negative 8 plus 6 is negative 2. So I know now that b is also negative 2 by coincidence. So that's all I need to write an equation. Since they do want it in slope-intercept form, this is the one. I don't have to do anything different to it. So now put it all together. So now you put y equals the slope, negative 2x plus your b. But it's not a positive number, it's a negative. And that is the equation they want me to do for question number 1. So for these, they want you to write an equation in slope-intercept form. Same thing, same process. So y equals mx plus b is what it should look like. So let's find two things. We're going to find the slope. So m equals, and I notice this line is going down to the right, so I know my slope is negative. And let's see how much I rise and run. 1, 2, 3, 4, 5, 6. So I rise 6, I run 1, 2. So my slope in this case is negative 3, or 3 over 1. And my b, the y-intercept, it looks like it is crossing there. So we already know that b is 9. So b equals to 9. So put it all together. Y equals negative 3x plus 9. And so for the next problems, you're going to have to find whether you're going to have to find a line that's parallel, that passes through a particular point, and so on. So let's go ahead and do this one that's perpendicular. So it says to write an equation in slope-intercept form of a line that satisfies whatever they tell you. So let's look at number 2. I know that if it's going to be perpendicular to this line right here, then my new slope is going to have to be the negative reciprocal of that number. That number right now is negative 3 over 1, so I flip it 1 over 3. It was negative, so now it becomes positive. So that's my slope of a line that's perpendicular to that one that they gave us here. And now it passes through this point, but I don't know the y-intercept. So let's find the y-intercept like we did before. So this is x and y. I'm going to use the same y equals mx plus b to find my, my b. So I know a y is 1. 1 equals to 1/3, that's the slope, times x is 3, plus b. Well, this is nice because 3 on top, 3 on bottom, they cancel, so 1 equals to 1 plus b. And so if I move the 1 over, that's minus 1, so b is equal to 0. Oh, so it looks like it's a direct variation. So it didn't ask about that, but remember the direct variation doesn't have a b, it's 0. So this is a simple equation, one that is perpendicular to it. It's quite simple. You just write it y equals your slope, which is 1/3 x, and then the b is 0, so that's it. You can stop there. So I just found a line that is perpendicular to the one that they gave me. In your practice problems, you're going to do the same thing. You're going to write equations with the slope and the y-intercept that they gave you. Same thing here, and pretty much the practice problems are going to be like the ones we did.